Hello everyone, welcome to this video on converting polar equations to Cartesian equations and Cartesian equations to polar equations. So I got the guided notes here. We're just going to start right into it with the first one. Everything you need to know to convert was in the first video, all those identities. So we're just going to jump in here. X squared plus y squared equals 9. So when I'm converting from Cartesian to polar, Cartesian I have only x and y's. In polar, I want only r's and thetas. All right, I'll write some of our identities over here as a reminder, also to help remind me. And then, well, it's just tangent. All right, so those are some of the new identities that some are new. These three are new. These you should know from beginning of quarter 3. So if I want to take all my x's and y's and change them to r's and theta, well, x squared plus y squared is x squared plus y squared is equal to r squared. So I'm going to write r squared. I'm going to substitute r squared equals 9. I want to get r by itself, square root both sides. R equals plus or minus 3. And that's your answer. That's it. Okay, let's go to the second one. Now, there are graphs on these notes. I'm not teaching you graphing this year. I have them on there, so at least you're exposed to it. That's why the graphs are on there. We're only doing conversions this year, though. Now we have x squared plus y squared equals 6y. Once again, x squared plus y squared is r squared. So we got r squared is equal to 6y. And y is equal to r sine theta. So r squared is equal to 6r sine theta. Divide both sides by r. R is equal to 6 sine theta. And there's your answer. Okay, now that example 8 on the next page. Let's see here. Y is equal to 3x plus 2. So y is r sine theta. So we got r sine theta equals 3 times x. X is r cosine theta. So r cosine theta plus 2. I want to get r's by itself, so I'm going to subtract 3r cosine theta from both sides. So then we get r sine theta minus 3r cosine theta equals 2. I'm going to factor out a common factor here of r. So then we have sine theta minus 3 cosine theta equals 2. This is r times, so to get r by itself, I'm going to divide everything by sine theta minus 3 cosine theta. The same here. And so we get r is equal to 2 over sine theta minus 3 cosine theta. There's your answer. Let's see here. Next one. There's a couple ways to do this. I'm going to show you the long way. I'll show you the short way. All right, so we can just start off by substituting here, right? So we have y squared. Y is equal to r sine theta. So we have r sine theta squared is equal to 3 minus r cosine theta. Right, that's what x is, squared. So then we have r squared sine squared theta is equal to 3 minus r squared cosine squared theta. Add r squared cosine squared theta to both sides. We have r squared sine squared theta minus r squared, or plus, excuse me, cosine squared theta equals 3. Greatest common factor is r squared, so we're going to factor out r squared. Equals 3. Let me see if we're still going here. Yep. Now, this is a Pythagorean identity. Sine squared plus cosine squared is equal to 1. So we have r squared times 1 is equal to 3. So then we have r squared is equal to 3. Square root both sides. R is equal to plus or minus the square root of 3. Okay, now the quicker way of doing this, y squared equals 3 minus x squared. Add x squared to both sides. We get x squared plus y squared equals 3. X squared plus y squared is r squared. Square root both sides. All right, that's a little bit quicker method, as you can see. Either way works. All right. Now we're going to switch over, and we're going to convert polar to Cartesian. Okay, this one's polar to Cartesian is not as intuitive sometimes, all right? So sometimes you have to kind of play around with it until you see something. So we have r equals 2 secant of theta. So let's see here. I'm going to divide both sides by secant theta. Now, when we're going from polar to Cartesian, I want all the thetas to turn into x's and y's. I want all the r's to turn into x's and y's. All right, so I'm going to Cartesian. I only want x's and y's, no r's and thetas. So now I have r over secant theta is equal to 2. Now this is the same as r over 1 times 1 over secant theta. 1 over secant theta, right, the reciprocal identity is cosine. So it's r cosine theta equals 2. What does r cosine equal? X. X equals 2. And there's your answer. Let's see here. R equals 3 over 1 minus 2 cosine theta. Well, let's get rid of our cosines and or our thetas and our r's. I'm going to multiply both sides by 1 minus 2 cosine theta, so that these reduce. Right, this reduces. So we have r times 1 minus 2 cosine theta equals 3. I'm going to distribute the r. So r times 1 is r, minus 2r cosine theta equals 3. R cosine theta is equal to x. So I'm going to substitute x in there. So r minus 2x is equal to 3. Now, I got to get rid of this r. The only thing I have over here is r squared. So I can square both sides and get r squared. I'm allowed to do that, right? Algebra says whatever I do to one side, I have to do to the other. But if I square this side, then I'm going to have r's and x's mixed together when I distribute. So what I'm going to do first is add 2x to both sides. So we get r is equal to 2x plus 3. And now if I square, I have r by itself still. So I have r squared is equal to 2x plus 3 squared. R squared, when I distribute this, I get 4x squared plus 12x plus 9. R squared is equal to x squared plus y squared. Right, and now we have an x squared on both sides, so collect like terms. Y squared is equal to 3x squared plus 12x plus 9. There's your answer. right? Now we have r is equal to 2 sine theta. So we have r is equal to 2 times. Now, sine theta is equal to y over r. So we'll go y over r. To undo division, I multiply, so I multiply both sides by r. So these r's reduce. I get r squared is equal to 2y. And r squared is x squared plus y squared. There's your answer. So good. And our last one here, r equals sine of 2 theta. Now, I don't got anything over there that's sine of 2 theta, just sine of theta, so I'm going to use my double angle identity that we had talked about at the beginning of the week in our identities video. So sine of 2 theta is equal to 2 sine theta cosine theta. Now I can switch these. So r equals 2 times sine of theta is y over r. Cosine theta is x over r. When I multiply fractions, I multiply straight across. So 2 times y times x is just 2xy. 1 times r is r, times r is r squared. R squared is equal to x squared plus y squared. Now I just got to get rid of this pesky r. Once again, we're going to square both sides. So now we have r squared is equal to 2 squared is 4, x squared is x squared, y squared is y squared. And then down here we have x squared plus y squared, quantity squared. R squared is x squared plus y squared. Here we have that. I'm going to multiply both sides by x squared, y squared, squared. Squared. So times x squared plus y squared, squared. That reduces this. So I have x squared plus y squared times x squared plus y squared, squared is equal to 4x squared, y squared. Now these are the same number, right? X squared plus y squared. So that means if I have something multiplied, if I have something squared, it's multiplied twice. So if I multiply by the exact same number again, it's cubed. So this is going to be x squared plus y squared to the third power equals 4x squared, y squared. And you're done. All right. So that's it for the video. All right, just 4 examples of each, and then make sure you do the practice problems. Practice problems are obviously uploaded to Canvas. Also, if you were in class at the time, your practice problems will be on the back side of your notes. If you weren't in class at the time, and you don't have the notes, then the guided notes and the practice problems are separated on Canvas. In class, they were combined together. Okay, it's the same thing, just on Canvas. There's 2 different links instead of just one single link. Okay, but that's it for the video. As always, I'm here after school every day. Come talk to me if you need anything.